Okay, in this video we're going to continue analyzing our quantitative data. Okay, so we had this set of a random sample of quiz scores from a class of 136 students. Okay, and we're being asked to create a stem plot for the data using split stems. Okay, now to make creating a stem plot easier, we can come over here, make sure that we enter in our information, all right? But our information may not be sorted to begin with, right? We might have our particular data values and they may not necessarily be sorted to start, right? So what we can do is we can go to Stat, Sort Ascending, right? And choose our particular list that we're working with to sort in an ascending order. And when I go back to my stat piece, right? So my stat button down here right at the bottom, when I go back to that stat piece, then I can come over, look, and now whatever I have sorted in ascending order will now be sorted. Okay, so here is my sorted in ascending order. So if I want to create my split stems, right, what I will have is I'll have 2 stems for my 70s, 2 stems for my 80s, and 2 stems for my 90s, right? And if I look at this, okay, so I'm going to go from 70 to 74, so that only has 74. 75 to 79, so that gives me a 5 and an 8. Okay, 80 to 84, well that just gives me the 80 and the 84. 86 to, or excuse me, 85 to 89, that just gives me 86. Right, then I have 91, 93, and then finally I have 98. So there is a split stem plot for my data, right? That I've taken this data and I've split it into the stems. It is always very important to have the key for your data. And so in this case, my key might be written as such, that this represents a quiz score of 74. Okay, that would be my data with split stems. If I was not going to split the stems, then I would only have, right, in this case, 7, 8, and 9, and I would have 4, 5, 8. And then I have 0, 4, 6, and I would have 1, 3, 8, right? And for both of these, right, I get the general shape of my data and kind of be able to see kind of particular details as to where students might be scoring more frequently or less frequently, right? So I can see that information. Now, if I want to create a histogram for this data using 3 classes or 3 bins of equal width, and truly speaking, when you're creating a histogram, your bins or your classes are always of equal width. I can come and I can look to my data. Well, now nicely, the 70s, the 80s, and the 90s are going to be these 3 classes of equal width, right? I'm going to have 10 possible values that could go into the 70s, 10 into the 80s, 10 into the 90s, right? So I can come over here and I can say, okay, well, let me get my horizontal axis. So set up to a horizontal axis. Let me get my vertical axis. So set up to my vertical axis. All right. I can have a break in my axis by making these little jagged lines. And I can then work through, and if I want to get equal spacing, I can use a handy dandy ruler and come over here and say, okay, well let's say that I am going to have these 3 classes of equal width, right? So I'll go ahead and say that here are going to be my 3 classes. All right, so there I have, and then I might mark the center of each of these classes to help distinguish, right, my items. And I also need to have a label right, that this is going to be my frequency on the vertical axis, and I have my equally spaced tick marks, and for this one it's going to be pretty straightforward that each of the tick marks will represent one. Right, on my horizontal axis I have to label that as well, and this represents quiz grade. Right, so for this particular one, right, I would be able to come up and say, hey, here I have a frequency of 3, right, for that bin or that class, and I have a frequency of 3 for that bin, and I have a frequency of 3 for that bin, right? So there I have now my histogram. Okay. If instead I'm asked to create a box plot for my data, it's necessary to have my 5-number summary, right? So I need my 5-number summary in order to create a box plot for my data. We can get that information from the calculator. Come over, right, and click on Stat, calculate, one variable statistics, wherever your list happens to be. Right, so if you had list 5, you'd switch to list 5. We happen to be in list 1. Oops, let's clear this. All right, press enter, and it'll get me my calculations. Right, scroll down, and here I have my 5-number summary. Right, and that 5-number summary was that we had a minimum, right, a quartile 1, a quartile 2, right, a quartile 3, and a maximum, and those values were 74, 76.5, 84, 92, and 98. Okay, so if I want to create the box plot for my data, right, I need to go ahead and set up my scale. You can use the nice ruler to be able to get things nicely labeled. All right, so I'll go ahead and come over and we can use this, that's fine. All right, so I know that I need to go from 70 to about 100, right, because my minimum is 74, my maximum is 98. So I might come over, right, draw a horizontal axis, right, and then I might say, okay, well here we'll say 70, 75, 80, 85, 90, 95, 100, and that would take care, right? Or possibly I could extend if I needed more pieces, right? Come over and say extend it in a different direction to what I'm looking to have, and sometimes you might have to extend even further still, right? Just depends on how you want to set it up. Right, so I'll go ahead and say that over here is going to be 100, right, that this is going to be 90, that here is going to be 80, here is going to be 70, right, and if I had these other pieces, I still need to label that axis, right, and this axis, once again, right, still needs to be told what it represents. So this represents the quiz grade, right. I don't really have a vertical axis here. But if I had multiple, right, box plots that I was going to show together, right, then I might come over and say, oh, okay, well, what is it that I'm going to come and show, right? I might have the vertical axis like, hey, box plot 1, box plot 2, go so on and so forth. But in this case, we have a minimum at 74, so I'm going to come over here and kind of estimate about where that minimum is. All right. Then we go to 76.5, so I'll kind of go and estimate about where 76.5 is. All right. Then I go all the way to 84, so I estimate about where 84 is. Then I go up to 92, so I'll estimate where 92 is, and then on up to 100. So there I go on up to 100. Okay. So I set this up, and now I need to draw my box plot. All right, so I can come over and I can make a vertical line through quartile 1, vertical line through quartile 3, a vertical line through quartile 2. All right. Set this up, and there, now I have a box plot. Right? I have my nice box plot for my data. Okay. Now, if I'm going to describe the distribution of data, I could describe the distribution from my histogram, or I could describe the distribution from my box plot. If I have, both, I can use either one to describe it. Okay. When I'm describing, SOCS will be a nice acronym that I can use, right? That acronym SOCS really is going to be saying the things that I should always discuss when describing a distribution of data are the shape, any outliers, right? Or any gaps, any unusual features, the center, and the spread. Okay. Now, I'll have some options. I'll have some options for some of these. Okay. The options that I'll have for some of these are, if I have the center, right? If I have the center, I could speak to the median, or I could speak to the mean. Okay. If I'm talking about the spread, I could speak to the interquartile range. I could speak to the standard deviation, or I could speak to the range. Okay. Now, the median and the interquartile range are going to be called resistant, right? While the mean, standard deviation, and the range are, we're going to say, affected by outliers, right? That means standard deviation range is definitely going to affect our results, right, from outliers. Okay, and the shape, right? The shape, the different things that we can talk about are whether we are skew, symmetric, or uniform, right? We could also discuss whether we are bimodal or multimodal. We could discuss the modality, right? And for the outliers and the gaps, really what we're looking at is that we're discussing any unusual features. Okay, so how would we describe the information here? All right. Well, if I have a histogram, I could discuss the center with the mean or with the median. If I have a box plot, I should use the median. All right. So in general, it's preferred to use the median when describing, and in general it's preferred to use the interquartile range when describing. And once again, that's because the median and the interquartile range are resistant. So, describe the distribution of our data here. We might say the distribution of quiz scores from our sample is uniform with no apparent outliers. Right? The median score was an 82. And the interquartile range was, and how do we find, right? The median was an 82, the interquartile range was, and how do we find the interquartile range? Right, we subtract the quartile 3 minus the quartile 1, so 92 minus 76.5. All right, I can come to my calculator if I'm not comfortable doing that in my head. 92 minus 76.5. And I can say that the interquartile range was 15.5 points. Okay. Right. And once again, just so we're sure, that inner quartile range is quartile 3 minus quartile 1. Right. So there we have our description of our distribution. We include our shape. We include any unusual features or if there are no outliers. All right. We include information about the center, in this case the median, and we include information about the spread, in this case the interquartile range. Okay. Note that the range or the interquartile range is a single number. Okay. So that gives us a little bit more analyzing and displaying quantitative data. All right. And these should be items with which you are very comfortable in producing and working through. All right, make sure that you always do ask questions for clarification as needed. Thank you very much. This has been Maths with El Profe Lo.